Age-related hearing loss is the third leading chronic health disorder affecting people over the age of 65. It has been associated with cognitive impairment, cognitive decline, and increased dementia risk. Hearing loss is prevalent in individuals with mild cognitive impairment, which is considered a risk state for Alzheimer's disease, with 10 to 15% of individuals with mild cognitive impairment developing Alzheimer's disease per year compared to 2% of healthy elderly controls. Both individuals with age-related hearing loss and MCI show increased connectivity in the anterior default mode network and decreased connectivity within the posterior default mode network. The current study investigated the effect of hearing loss on default mode network connectivity in individuals with mild cognitive impairment. It was expected that in individuals with MCI, hearing loss would be associated with increased connectivity within the anterior default mode network and decreased connectivity within the posterior default mode network due to the greater recruitment of frontal regions in those with hearing loss, in addition to having a cognitive impairment. Data were obtained from the CCNA's Compass ND study and included 40 adults with mild cognitive impairment matched on age, education, and gender. To screen for pure tone hearing loss, 2 kHz pure tones were tested at 25 decibels and 40 decibels twice in both ears for every participant. Pure tone scores were categorized into 6 groups based on previous studies from our lab. The histogram depicts the distribution of the hearing categorizations for the hearing loss group. Due to the rare nature of the category hearing loss 4, there were no participants with this type of hearing loss included in the analyses. A group independent components analysis was used to extract the default mode network from participants' resting state fMRI data. A 2-sample t-test was then used to investigate if mean default mode network connectivity differed between the normal hearing and hearing loss groups. In a second set of analyses, the posterior cingulate gyrus, posterior cingulate cortex, medial prefrontal cortex, and a region in the parietal cortex were used as seed regions to investigate if default mode network connectivity differed as a function of hearing loss. Results from the independent component analysis indicated no statistically significant difference in mean default mode network connectivity between the two groups. Seed to voxel analyses revealed significant functional connectivity differences across groups. Individuals with hearing loss showed decreased connectivity between the posterior cingulate gyrus and the posterior cingulate cortex and regions of the caudate, the nucleus accumbens, and the thalamus. Moreover, they showed increased connectivity between both the medial prefrontal cortex and a lateral parietal seed region and regions of the occipital cortex, including the left occipital pole and the left and right superior lateral occipital cortex. Results from the seed to voxel analyses were consistent with previous findings in cognitively normal individuals with hearing loss. These findings suggest that hearing loss is associated with the reorganization of the default mode network and the visual cortex in individuals with concurrent MCI and hearing loss. Limitations include the small number of participants, the collapsing of hearing categories in the hearing loss group, and the use of pure tone scores to define hearing loss. Future directions include a larger sample size, the inclusion of cognitively unimpaired older adults, and the use of speech reception thresholds to measure hearing loss. I will also investigate if sex influences the relationship between hearing loss and default mode network connectivity, as there is a higher prevalence of hearing loss in men, a higher prevalence of dementia in women, and few studies that disaggregate by sex.